In question 2, we have to specify whether each of these 6 given statements, they are true or false, and we have to give reasons for our answers. So here's what the first statement says. The line segment joining the center to any point on the circle is a radius of the circle. So here's an example of a circle, and let's take any point on the circumference on the circle itself, and if we join the center to this point, then we get a radius of the circle. So this first statement is true. Joining the center to any point on the circle gives us a radius of the circle. Okay, the second statement says a circle has only a finite number of equal chords. So basically this means that the number of equal chords, the statement says that the number of equal chords in a circle. Okay, now the second statement says that a circle has only finite number of equal chords. Now this is clearly a false statement, and the easiest way to understand why it's false is to think about diameters of the circle. So a diameter is also a chord of the circle, and we know that in a circle we can draw infinitely many diameters. So draw any chord through the center and you get a diameter. So a circle will have infinite number of equal chords. So this second statement is false. Okay, now the third statement says that if a circle is divided into 3 equal arcs, each is a major arc. So let's draw a figure for this. So here I have drawn a figure in which we have a circle which is divided into 3 equal arcs, AB, BC and CA. And the statement basically tells us that each arc is a major arc. But you can visually see that this is not possible, because if each arc is a major arc, then if we add them, they will add to more than a full circumference. And the way to write it out properly as a proof would be to, let's say, look at one of the arcs. So let's say if we take the arc AB, and if we now consider the other 2 arcs put together, so the other 2 arcs put together will be BCA. Now arc BCA will have a length greater than arc AB. So let's write this. So arc BCA will have a length greater than arc AB, because BCA is 2 of these arcs put together. And we also know that arc AB plus arc BCA gives us a full circle. So this means that if arc BCA is greater than arc AB, then BCA has to be the major arc, and which means that AB has to be the minor arc. So arc AB must be the minor arc. Similarly, BC has to be a minor arc, and CA also has to be a minor arc. So in part 3, all the 3 equal arcs will be minor arcs. So this statement is also false. Now in part 4, the statement says that a chord of a circle which is twice as long as its radius is a diameter of the circle. So this statement is actually true. If you have any chord passing through the center of the circle like this, it's a diameter of the circle, and this is twice of the radius of the circle, because the radius is the a segment joining the center to any point. So if you double this, you get a diameter of the circle. So statement 4 is true. Now in part 5, the statement says that a sector is the region between the chord and its corresponding arc. So in this circle, let me draw any chord. So let's take this chord, and the corresponding arc of this chord would be this arc here, right? And now basically the statement says that the region between the chord and the arc is the sector. So if we take this region, this is the sector. But this is not true, because this region is actually called segment, not sector. And a sector is basically when you take an arc. So let's say we take this arc, and we have the 2 radius drawn at the endpoints of the arc, and we take this whole region. This is a sector. So this is a sector and what's referred to in the statement is a segment. So the statement in part 5 is false. Okay, finally in part 6, the statement says a circle is a plane figure, which is true because all points on a circle lie in the same plane. It is not a three-dimensional figure. So the statement in part 6 is true, and with this all parts of question 2 are done.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.